Unit 3, Lesson 9, Introduction, Factoring by Grouping. A common factor is not necessarily a monomial. For example, a times x plus 2 in brackets plus b times x plus 2 in brackets has a binomial common factor of x plus 2. So your common factors can be expressions in brackets. And the way you factor these out is the same way you would factor out a monomial. Okay? Recall binomial meaning two terms. Okay, so let's factor some expressions that have a common factor whose common factor is a binomial. So here, look at the first one. We have a y plus 1 as the common factor. So you write out the common factor, y plus 1. So what we're doing is we're dividing out that common factor, and then you write out the leftovers. So what's left over? 3x times y plus 1 divided by the common factor is 3x, and 7z times y plus 1 divided by the common factor is 7z. And there you go. Okay? Right? Another way to think of it is you're factoring out, meaning these things go outside again, right? The reverse distributive property. So you're going to reverse the distributive property here. Your common factors for the second example, kind of bring them out, right? We're reversing the distributive property. So you're going to say, okay, common factor, x minus 3. And then what was in your brackets left over? 2x and minus 5. Okay, and there's your factored form. So often there's no common factor for all the terms in a polynomial, but some of the terms have a common factor. A process of factoring by grouping can sometimes be used with these polynomials. This process involves factoring groups of terms first instead of factoring the entire polynomial. So instead of the entire polynomial, if you look at part A, you have x times ay, 2x plus 2y, etc., etc. But you can't common factor the whole thing, okay? But we can common factor groups, right? We can common factor this pair of terms, we can common factor this pair of terms. So we can factor out an a. So a comes out, ax divided by a is x, ay divided by a is y, so plus y. We can common factor out these 2's, okay? So plus 2, 2x divided by 2 is x, and 2y divided by 2 is y. And then you'll notice we have still common expressions, x plus y, and those could be factored out as well, right? These can come out as well. So here in front, x plus y, and inside my brackets is the leftovers, a plus 2. Okay. Now, for this next one, again, no common factor between 9, 15, 3, and 5, right? You think 3 you can divide 9 by 3, 15 by 3, 3 by 3, but 5 can't be divided by 3. So in this case, again, look for pairs. Pair them up. Look for a common factor. Okay? 9 and 15 have a common factor of 3. And there's at least one x, so a common factor out of 3x. Okay? Create your brackets. 9x squared divided by 3x is 3x. 15x divided by 3x is positive 5. 3x and 5, nothing else. Common factor of 1 if you want. Okay, but by writing it out there, we have common expressions. If it helps, put the 1, common factor of 1. Okay, factor out the common expression. So out in front will be 3x plus 5. What's left over? 3x and a plus 1. In the beginning, it's a good idea to write out the 1 because you don't want to forget the invisible one. It is part of the expression that you create at the end. And there you go. That is just a quick brief overview of common factoring groups.